In this video, I'm going to show two examples of graphing rational functions. And here's our steps. First, we need to get our intercepts. Then we'll figure out our asymptotes, both the vertical and horizontal, and if there's any touch points. And then we'll plot some extra additional points to get a sense of what that graph looks like. Okay, here we go. So our first one, we've got f of x equals x squared minus x minus 6, all divided by x squared minus 5x minus 6. Okay, to get the x-intercept, that is when our function's output is 0. And so that happens when the numerator is 0. Because if you take the entire function and set that equal to 0 and then clear out fractions there, you just end up getting x squared minus x minus 6 equals 0. Okay, so to find the x-intercept, we set the numerator equal to 0. That's our process. And then solving that, let's see, we would get x minus 3 and then x plus 2 is equal to 0, and we factor that out, and the zero product property gives us x equals 3 is a solution and x equals negative 2. So there's our two x-intercepts. At negative 2 the output is 0, and at 3 the output is 0. I'm going to graph those. 2, 3. Okay, perfect. Now we need to get our y-intercept, and that's when our function's input is 0. And we just get 0 squared minus 0 minus 6 all over 0 squared, 5 times 0. So all those x's are just 0, and that ends up being 1. So our y-intercept is 0, 1. And now we want to start looking at the asymptotes. I'm going to start with my vertical asymptote, and that happens when the denominator is 0. Okay, because that would give us when our function is undefined, and that's the exact definition of the vertical asymptote. Okay, so we get our denominator, x squared minus 5x minus 6 equal to 0. And this one factors as x minus 6 and x plus 1 equals 0. And the zero product property gives us that x equals 6 and x equals negative 1 are both solutions. And those are our vertical asymptotes, so I'll show those. And you just want to show those as dotted lines there. And the function is never going to cross a vertical asymptote. 3, 4, 5, 6. So once we've found those, now I can say what my domain is. I can go from negative infinity up to that first asymptote, can't touch it, and then I go from there to the second asymptote, and then I go everything beyond that next asymptote of 6. So there's our domain. And we're getting close. Now we want to find our horizontal asymptote. And we take and divide x squared minus 5x minus 6. And when you're doing the division here, you're basically just looking at the leading terms, because that would be the first step when you're dividing polynomials, to find out how many times does that divisor go into the dividend. So that's really all we have to look at, is just take those first terms. So this is my horizontal intercept. All right, and now we need to know if there's any places where our function might touch or cross that horizontal intercept. I can go ahead and plot that as well. And we see that there is one right there at the y-intercept, but let's see if there's any more. Okay, so to find our touch or cross points, you take your function and set it equal to what you just found for the y-intercept, and in the book that's d, but it's just whatever that number is that you just found for your, I said y-intercept, but I mean the vertical asymptote. So whatever that value is, plug that in and let our function equal 1 in this case. All right, so we take x squared, our function, minus x minus 6, and that's all over x squared minus 5x minus 6, and set that equal to 1. And then I like to just set cross products equal. So I get x squared minus x minus 6 is equal to x squared minus 5x minus 6. And I'll add 5x to both sides. And so I've got 4x minus 6 is equal to negative 6. Add 6, and we'd get 4x equals 0. Dividing by 4, we get x equals 0. So the place where it either touches or crosses is when x is 0, and then the y value right there is 1. So there's our touch, and we had already found that because that was the y-intercept that we found right here. Okay, so now we're really close to being able to graph this. We know what the domain is. We've got a lot of the key information. We just need a couple additional points to get a sense of what's going on with the graph. So I'm going to try -3, I'm going to try 4, and 7. And hopefully that's enough to give me a sense of what this graph looks like. Okay, putting in -3, I'd get -3 squared minus a -3 minus 6 all over -3 squared minus 5 times -3 minus 6. And that whole thing simplifies down to about 0.3. And now when we input 4, we get about -0.6, and inputting 7, we get 4.5. So I'm going to go ahead and graph those. -1, 2, 3 is a positive 1/3, and at positive 4, 1, 2, 3, 4, we're at a -0.6, and then at 7, 1, 2, 3, 4, 5, 6, 7, we're up at 4.5. 1, 2, 3, 4.5. Okay, so given the fact that a vertical asymptote is defined as the place where my function approaches positive or negative infinity. Okay, so since there was a x-intercept here, my function really doesn't have any other choice but to head down and approach negative infinity. And then it's approaching that horizontal intercept of 1 as my x values decrease. All right, and then here there's only one place where the function either touches or crosses, and so based on the fact that my function has to approach positive or negative infinity as it approaches those horizontal asymptotes, I can get a pretty good sense of what that graph is looking like. So there is my function. So quite a bit of work. The first step is to figure out your intercepts, then get your asymptotes, and then put a couple more points in. So let's try another one. Let's see, 3. So first I'm going to find my x-intercepts, and you set your function equal to 0. So go ahead and pause the video and see if you can figure out what those are. We set our function equal to 0, and then remember that when we clear fractions, we end up just getting the numerator equal to 0. Okay, so we should have the x-intercept there when x equals 0. So 0, 0 is our x-intercept. Okay, next step is the y-intercept. So take a minute and see if you can remember how to do y-intercept. Go ahead and pause. Okay, we should have a y-intercept of 0, 0, and now it's time to start working on our asymptotes. So let's do our vertical asymptote first, and pause while you try and remember how to get your vertical asymptote. So the vertical asymptote is when the function is undefined, and that happens when our denominator is 0. So set your denominator equal to 0. And there's your two x or your two vertical asymptotes. In this case, there's two of them. Sometimes there's none, sometimes there's one, you know, it just depends. We just got to figure them out. Here there's two. So there they are. Go ahead and graph those. Okay, next up is the horizontal asymptote. I'll give you a minute to work on that. Okay, the process here is we divide leading coefficients, ignoring the remainder. So y equals 2 is our horizontal asymptote. Okay, now we need to do our touch points. Go ahead and pause and figure those out for yourself. All right, so we end up not having any touch points. And now you're ready to get a few additional points, write out your domain, and graph your function. So let's look at our domain. So our domain goes from negative infinity to that first vertical asymptote, and then it goes in between the two asymptotes, and then it heads off from 2, not touching 2, but heading everything bigger than 2. So there's our domain, and now the additional points we need. I'm going to just do just enough so I can see what's happening here. I'll give you a minute to work on these. So let's put in -3, -1, 1, and 3. Okay, so take a minute and work those out. Plug those into your function and figure out the output. All right, so there's our approximate outputs, and when we go ahead and graph this and put it all together, I'll give you a minute to do that, and then we'll come up with our graph. So go ahead and finish, figure out what you think that graph might look like. I'll give you a minute to do that. Go ahead and pause. And there's our function. Done and done.